Hello and welcome back. Geometry section 3334 today, combination lecture, slopes and equations of lines. What we're going to do is we're going to cover kind of like a major review from algebra, okay, going through here. First thing we need to talk about is the concept of slope and the slope of a line. We know that given any line that exists on the coordinate plane, we can find how far it goes up and over, okay, our rise over our run idea. Okay, and algebraically, given 2 points on a coordinate plane, we do have our formula here for rise over run, okay, down here in the bottom right. The slope of a line is equals m, as we refer to it as, and it's rise over run. The y's, as I would say, rise to the y's over the x's. So the slope formula we have here also on the left, we have y2 minus y1 over x2 minus x1. So we have this concept of slope that we need to review from algebra. Okay, and a lot of lecture today will be a review. Just going through the idea and the types of slopes that we can encounter. There are 4 types of slopes that we can look at. There is the positive slope, okay, where it's increasing from left to right. There is the negative slope, which will be decreasing from left to right. There is the zero slope, okay, and we'll talk about this more later, but this slope will be a constant, which will be a y equals something. Okay, it is a zero slope. And then we have our undefined slope, which is like a vertical line, and that is an x equals something. So for the positives and negatives, okay, obviously m is equal to a positive number. Here we have m is equal to a negative number. And then for the specific examples, zero slope and undefined, we have a y equals equation, and an undefined slope would be an x equals equation. Okay, again, all things reviewing from algebra. Alright, let's apply then on some examples. Finding slope. Again, slope is rise over run. Okay, y's over x's. I always think rise with the y's. Okay, so you always want to make sure your y's are on top. Okay, going through. And we want to find the slope of the line given this picture. Okay, first thing we want to notice here is we have the y-intercept at 2. Okay, the y-intercept is the point where it crosses the y-axis. The y-axis on top and the x-axis going left to right horizontal. So we have 2 being the y-intercept, okay, and we have to find our next point that hits a coordinate here. So off to the right, if I went over, I say I have a point there that is on a nice number, okay, and also here to the left I have that one there. And if I look about the distance between the distance up and over from that point and up and over, the first thing that I note is that it's a positive slope. Again, it's increasing going from left to right. The second thing I want to do is I want to count how many I went up, and I went 1 up and over 1, 2, 3. So I'm going up and over 3. So I'm going up 1 over 3. Again, we want to rise with the y, so we have our y's over our x's. So we are going to go ahead and make the statement that our slope, okay, for this equation or for this line, okay, is 1/3. We're rising 1 and we're running 3. Okay, so the slope of the line is 1/3. Alright, finding slope from points. Here we are here with our slope equation. Again, slope is equal to again, the x2 or the y2 or the y1 is front. It doesn't really matter as long as you're consistent. Here we're using y1 minus y2 and x1 minus x2. Alright, so given our point, find the slope of the line that passes through the points 0, 6, and 5, 2. We go ahead and plug it into our slope formula. Okay, so here we are reading our slope formula from left to right. M, of course, was our variable. It doesn't matter which one we start with, y sub 1 or y sub 2, as long as we're consistent. We're picking our y sub 1 to be 6, which means our y sub 2 is 2, and then we have x sub 1, x sub 2. So labeling those on the right, we can follow along. 6 minus 2 is 4, 0 minus 5 is negative 5, so our slope of that line is a negative 4/5. It's irrelevant whether the negative's on top of the fraction or the bottom. Either way, it's negative. If there was both negatives on top and bottom, then it would be a positive number. Let's take a look at another example. Find the slope of a line that passes through the points -3, 0 and 4, 7. Again, going through plotting out our points, we're going to go ahead and state that we have x sub 1, y sub 1, x sub 2, y sub 2. We'll take 0 then, minus 7, and negative 3, minus 4. Okay, because they are all positive numbers, because the second numbers are all positive, we haven't had to switch the signs, so we look at it going across. We have negative 7 over negative 7, which I said would be a positive number, and further than that is 1 for our actual slope. So the slope of this line will be 1. Alright, find the slope of the line given the 2 points. Now we can either do the formula, which is recommended going through, or we could count going down, seeing as how we have the picture right here. We do know that we have a negative slope going left to right as we're reading it because it's falling. The number is going lower. I'm going down 1, 2, 3. So I'm going down 3, and of course going over 1, 2, 3, 4, 5. Okay, so I know that the slope is going to be a negative 3/5. I can show that using my equation though. If I pick x sub 1, y sub 1, x sub 2, y sub 2, and I show my work here, I'll start off with the y sub 2's here. So I have 1 minus 4 over 2 minus a negative 3. Okay, and minus negative becomes a positive, so on top I have negative 3, and minus negative is really a plus 3. So I have 2 plus 3, which will then be 5, so my slope is a negative 3/5. So again, counting or by solving. It's much more efficient to do the solving because you can always count wrong. Okay, going through. And I had negative 3/5, of course, is our result. Same thing over here on the right, find the slope of the line. We know it's a positive, so therefore looking at our choices, we know it can't be B and it can't be C, it has to be either D or A. And if we look here and we put it in our slope formula, we have, let's do x sub 1, y sub 1, x sub 2, y sub 2. We'll end up with 2 minus a negative 4 and 5 minus 2. So we'll have 6 over 3, which is of course the number 2. So therefore the slope of the line will be D. Alright, and that's finding slope of the line. Again, a review from algebra. Alright, next thing, parallel and perpendicular slopes. If two lines have the same slope, then the lines are parallel. Here we have the slope of the line number 1 being 1/3, and the line 2 being 1/3 as well. Okay, and we can track that here. Up 1 over 3, up 1 over 3, up 1 over 3. Same thing in the bottom, up 1 over 3, 1 over 3, 1 over 3. So therefore, the lines are parallel because they have the same slope. Alright, our other one, perpendicular lines. If two lines have slopes that are opposite reciprocals, then the lines are perpendicular. Okay, and we have it noted that we do know from previous lectures that perpendicular means right angle, so we have a right angle marked there between the two lines. But what does it mean to be an opposite reciprocal? An opposite reciprocal flips the fraction. So if our slope here was 1/3, okay, it flips the fraction over, making it 3 over 1, and then it changes the sign. Okay, so the reciprocal part flips the fraction, and then the opposite part changes the sign. So I change the sign from a positive to a negative. Okay, and that works in both directions. Okay, if it was a negative, then it would flip into a positive. Positive turns into a negative. Okay, so that is definitions then for parallel and perpendicular lines. Okay, and another definition here, just stating parallel and perpendicular. We can kind of look at the figure here on the right. Okay, when we're talking about slopes parallel and perpendicular, these two lines are parallel here. They have slopes of 4. Okay, and a line perpendicular to those two has a slope of negative 1/4, as again, flip the fraction because a whole number can be written as 4 over 1. Flip the fraction, that's 1/4, and then they flip the signs, make it a negative going through. Okay, deciding perpendicular or parallel lines. Our question and our task is to determine whether the lines are parallel, perpendicular, or neither. So given a set of coordinate points here, one at negative, or a line at -2, 6 and 0, 1, another line being -6, 5 and -4, 0, we need to determine whether they are parallel, perpendicular, or neither. Deciding whether or not we have parallel, perpendicular, or neither, as far as the slopes are concerned, we need to find the slopes for the two lines. Okay, doing so in quick fashion here, we can show that the top left one, okay, going through here, this set of coordinate points has a slope of -5, 2, and our second set of points has a slope of -5, 2. So by working out the two slopes, okay, through the slope formula, we can show them that since they are the same, they would be parallel. Okay, so we just did the work really quick for you there, but you're welcome to go ahead and try the work for the problem. Okay, so since the slopes are the same, they are parallel. Alright, taking another example. Are these two lines parallel, perpendicular, or neither? So finding the slopes. Okay, again, we'll show the work here pretty quick. Coming in, finding the slopes of the left set of points and the right set of points. We have -1/2 and 2. Seeing as how the slopes are opposite reciprocals, we would say then that the two lines are perpendicular. The question comes up, is it neither sometimes? Does it ever happen? Yes, there's a lot of cases where lines are not parallel or perpendicular, they're neither. Okay, we just happen to show two examples where one was parallel and one was perpendicular. Alright, another example here. Determine whether AB and CD are parallel, perpendicular, or neither, for AB being at points -2, -1, and 4, 5, and then C and D at points 6, 1, and 9, -2. So finding the slope, okay, let's say we have x sub 1, y sub 1, x sub 2, y sub 2, y sub 2. We can use this to solve. Let's have -1 minus 5 then over -2 minus 4. Going through, we have -6 over -6 for 1. Taking a look at C and D, let's do x sub 1, y sub 1, x sub 2, y sub 2. We'll take 1 minus -2. We'll have, underneath that then we'll have 6 minus 9. Solving, we'll have 3 over -3 equal to a -1. Okay, again, taking a look at our two slopes then, we have 1 and -1. We would rewrite the top equation as 1 over 1 and the bottom as -1 over 1. So even though it doesn't look like it, the two lines, the two fractions for the slopes are flipped and are opposite, so therefore then we know that the slopes have to be perpendicular. So 1 and -1 are perpendicular slopes, and it's just kind of a funny way to writing them. It's not as concrete because of 1 over 1 being 1 and anything over 1 being 1. But the two lines are perpendicular because they have opposite reciprocals for slopes. Alright, moving on to our next topic, looking at slope-intercept form and point-slope form. Again, continuing on with our review of algebraic concepts, we do have an example of both the slope-intercept form, okay, going here, y equals mx plus b, and the point-slope form, which is the not as common, familiarly remembered one, as y minus y1 is equal to m quantity x minus x1. During our demonstrations on the lecture, we'll be using point-slope form for a large number of the problems, particularly when you're given a point and a slope, or 2 points and you need to find and write your final answer in slope-intercept form. Okay, going through two very specific equations that we will use to solve different problems. Okay, slope-intercept form and point-slope form. We also want to make note again of the thing we touched on earlier of the examples of a y equals equation and an x equals equation. X equals equations are undefined slopes. Okay, they go up and down. They are vertical. Y equals equations are zero slopes, and they are known as constant functions. So what we have here is we have kind of the opposite. X equals goes against the x-axis, it crosses the x-axis, and y equals goes against the y-axis and crosses that y-axis here. Okay, going through that y-axis. So it's kind of the opposite of the axis if you're trying to remember those two. Okay, is it the case that you need to necessarily memorize all four of those: the slope intercept form, point slope form, and y equals and x equals? No, not necessarily the case for the test, but you do have to know them. So in a sense, you guys can call it memorization, but for the test, you will have to know those formulas. Alright, example, write an equation in point slope form of a line whose slope is negative 3, 5 and contains the point negative 10, 8. Walking through our steps here, we know that we have our point slope equation as y minus y1 equals m quantity x minus x1, where the y1 and the x1 are the specific point that we're dealing with. Seeing as how we know that our slope is negative 3/5 and our point, again, x1, y1, we can replace in the information that we do know. Y minus 8 is equal to negative 3/5 quantity x minus a negative 10. We can simplify that statement then to y minus 8 is equal to negative 3/5 quantity x plus 10, and we shall have, excuse me, went too far ahead. We shall have our simplified answer here. So final answer left in point slope form is y minus 8 is equal to negative 3/5 quantity x plus 10. There will be some questions that you're asked to leave it in point slope form. The nice thing about point slope form is it tells you exactly what you need for that form. You need a point, okay, which we have negative 10, 8, and a slope, negative 3/5. Moving on. Question says write an equation in point slope form of the line whose slope is 1/3 that contains 6, negative 3. So by looking at our choices, we know one for sure is not part of the point slope culture, and that would be C. Definitely can't be C there. We have the slope being 1/3 and my point x1, y1 being 6, negative 3. Okay, looking through just by process elimination, it cannot be D. Alright, and we're left between A and B. If our original equation is y minus y1 is equal to m quantity x minus x1, and I replace in my negative 3 for y1, since there's already a negative there, I'm minusing a negative, and minus negative becomes a positive, so I have y plus 3 is equal to 1/3 x minus 6. Looking then at our choices, B is our correct answer. Next example, write an equation in slope-intercept form of the line with slope negative 1 and a y-intercept of 4. So this is the slope-intercept form, which was y is equal to mx plus b, where m is the slope and b is the y-intercept. And we have those two pieces. We have the y-intercept as 4, and we know that our slope is negative 1. Okay, so taking a look at our choices, we know it can't be A because it doesn't look even like the equation. Okay, again, the equation with a star next to it. We do have to take a look at choices B, C, and D. We have slopes of negative 1, and again, it cannot be B then because we don't have a negative slope, and we're left with choices C and D. We know that if we replace our values in, we have y is equal to negative x plus 4 because it's positive 4. Negative 1x just turns into negative x plus 4. Y is equal to negative x plus 4 for a final answer of D. Going through there as well. Alright, point slope versus solving for b. Now depending on your algebra experiences, things like that, your teacher may have expressed one liking method over the other, or one solving method over another. I prefer the point slope method, okay, which we're going to talk about first, but I will show both point slope and solving for b. Question states, write an equation of a line through the point 4, 9 that has a slope of -2. So now the point slope method, you start off with your original equation, which is y minus y1 equals m quantity x minus x1. We have our point x1, y1. We have our slope, okay, that's m, and we would just replace in the values that we have that are given to us. So we have y minus 9 is equal to -2 quantity x minus 4. At this point in time, if we want an equation of a line, it really means put it into a slope-intercept form, which means I have to have a y equals. So at this point in time, to get y by itself and have it equal, I need to distribute on the right side first. So I have y minus 9 is equal to a -2x plus 8. I would then go ahead and add 9 to both sides. Here I would have y is equal to -2x plus 17, and that would be my equation of a line that goes through the point 4, 9 and has a slope of -2. Now this was the point slope method. The solving for b method works directly with the slope intercept form and then solves using the solving where b is the focal point. So let's talk about that now. So slope intercept form, okay, the solving for b method really comes down to y equals mx plus b, okay, where if we have our two pieces of information, which is our slope m and our point, and they call it x and y here, what we want to do is be able to find the intercept, okay, or the y-intercept, which is the b. Okay, so we're trying to find b in the end. What we do know from this equation is that we do know that we have a point for y, which is 9. We have a slope, which is -2. We have a point for x, which is 4. And again, we're still looking for b. So the solving for b method then would solve for b, and we would simplify. 9 is equal to -8 plus b. We'd add 8 to both sides to get b by itself. We'd find out that b is equal to 17. Once we find out that b is equal to 17, we replace that b in the original equation with the slope that was given to us at -2. So therefore, our equation would be y is equal to -2x plus 17. Both equations come up with the exact same line, okay, or both methods anyways come up with the exact same line. Either method that you choose is okay. I'm going to do most of the problems from here on out with point slope, but if you have been used to solving for b method, you're welcome to go right ahead and do that. Okay, again, it all comes down to putting the equations in slope-intercept form. One is just solving for b, and one is using the other form that we've talked about. Going through. Alright, and here's just some animations from the slide in case we didn't have my writing. Alright. 2 points. It says write an equation in slope-intercept form for a line containing 4, 9, and -2, 0. So this is our multi-step problem in which we have to first come up with the slope, then put it, then use that slope and use one of the points to find the line that contains those 2 points. So walking through the steps, we know that our slope, after simplifying, is going to be 3/2. So our slope is 3/2 using the slope formula first. We then can use either the solving for b method, which we just worked through, or the point slope method to solve for the equation. We're going to use the point slope form. So finding the y1 and the x1 is irrelevant as far as which point we use, because you can use both the 4, 9 and the -2, 0. As long as you use the same x and y, it doesn't matter which point that you choose. Okay, so without worrying one way or the other, we'll pick 4, 9, and then our slope is 3/2. Okay, so plugging in the information that we know, plugged in 9 for y1, 4 for x sub 1, and then our slope was 3/2. Trying to get it into slope-intercept form then just requires us to get y equals, okay, or y by itself. So simplifying then with algebra, we use the distributive property. Okay, so we have y minus 9 is equal to 3/2 x minus 6. Then simplifying by adding 9 to both sides, we have our final equation, which is y is equal to 3/2 x plus 3. Okay, and this is taking 2 points and writing it in slope-intercept form. Okay, again, final answer, y is equal to 3/2 x plus 3. Next one says, write an equation in slope-intercept form for a line containing -3, -7, and -1, 3. Again, same way, find the slope first. The slope is the important part. Simplifying, our slope is 5. Again, we have to choose solving for b or point slope. Okay, we have the point slope, and we're also going to pick the point -1, 3. Putting in the information that we know, we have y minus 3 is equal to 5 quantity x minus a -1. Simplifying, y minus 3 is equal to 5x plus 5. And lastly, y is equal to 5x plus 8 when we solve. So again, starting with 2 points and ending up in slope-intercept form. Another example using the same symbols and things like that, or solving methods that we've talked about before. We'll work it out here on the side. We'll just pick x sub 1, y sub 1, x sub 2, y sub 2. So let's do this pretty quickly. 8 minus 2, 6 minus 3, 6 over 3 is equal to 2. So our slope is 2. Let's pick the first point. So we'll have y minus 2 is equal to 2 quantity x minus 3. Y minus 2 is equal to 2x minus 6. Y is equal to 2x minus 4 when we add 2 to both sides, which is C. Equation of a line. Y is equal to 2x minus 4. Alright, next example. Same type of question. Okay, this repetitive notion here should be getting our heads of practicing going through like that. Let's do x1, oops, y1, not y2, x2, y2. We'll do 10 minus 1 over 4 minus 1, so we'll have 9 over 3, which is 3. We'll use the first points here, so we'll have y minus 1 is equal to 3 quantity x minus 1. Y minus 1 is equal to 3x minus 3. Y is equal to 3x minus 2 then. Going through, and again, letter C as our value. Alright, let's see what we have. Horizontal line says write an equation of a line through 5, -2, and 0, -2 in slope-intercept form. So we have a horizontal line, as if we plotted this on a graph, we would have imaginary 1, 2, 3, 4, 5, down 1, 2, our point here, and 0, 1, 2, right? So the line would look like this. We want to write it an equation in slope-intercept form with that. So we'd solve using the slope formula, find out that it's 0. Okay. Once you have the slope being 0, we can go ahead and plug it in just like we've done before, and using either of the 2 points. So we're plugging in 5, -2 with our slope 0. Okay, solving then, we know what's going to happen to the right side, as it's going to be 0 times the right side, which is just 0. So therefore we have y plus 2 equals 0, and then we subtract 2 on both sides to get our equation, y equals -2. So it is the case that this is in slope-intercept form by being just a y equals equation. Okay, and again, we knew that from before, that y equals equations were the horizontal lines. Final answer again for that was y equals -2. Alright, writing parallel and perpendicular equations. Okay, continuing on here. question states, write an equation of a line that goes through the point 3, 2 and is parallel to line y equals negative 3 1/3 x minus 1. So the first thing we have to note here is, what does it mean to be writing an equation that's parallel or perpendicular? Well, it's just simply we're taking a look at the slope of the line that's given to us. We want to write an equation that is parallel to negative 1/3 x, that line. So y equals negative 1/3 x minus 1. We want an equation of a line that's parallel to that one. So the really only thing we need to look at is the slope itself, and the slope is negative 1/3. So if we want the parallel slope to that, we just use that slope and the point given to us, 3, 2, and we can use that then to write our equation. Okay, so taking the slope that we want, which is the negative 1/3, okay, and the point 3, 2, we can plug it into the point slope formula equation, and then we can just solve using the distributive property and addition, and we end up with y is equal to negative 1/3 x plus 3. So that is the equation of a line that goes through the point 3, 2 and is parallel to the line that was given to us at y equals negative 1/3 x minus 1. So the only difference is where we're getting our slope from. Now we're getting our slope from an equation of a line as compared to points that exist in space. Another example, write an equation of a line that goes through the point 4, 0 and is perpendicular to the line y equals negative 2x plus 1. So our slope in question is negative 2. You're going to ask yourself, if our slope is negative 2, what is a perpendicular slope to that? Opposite sign would be a positive, reciprocal flip, 1/2. So the slope that we're going to use is 1/2. The point that we're going to use is 4, 0. And using the same methodology going through here, we have our point slope formula, and we have our point 4, 0 and our slope 1/2. Okay, working through the point slope form, we end up with y is equal to 1/2 x minus 2. Okay, again, that is an equation of a line that goes through the point 4, 0 and is perpendicular to the line y equals negative 2x plus 1. Let's take a look at another example. Write an equation in slope-intercept form for a line perpendicular to the line y equals 1/5 x plus 2 through the point 2, 0. Walking through our steps, the slope of y equals 1/5 x plus 2 is 1/5, so the slope of a line perpendicular to that is negative 5. So here's our slope, negative 5, and we can go ahead and plug through the process. Okay, this time we're going to take a little different approach. We're going to use the solving for b method, just for demonstration purposes. We'll have y equals mx plus b. Okay, the m that we're dealing with is the negative 5, and the x is 2, and the y is 0. And using those three pieces of information, we can solve for the b then. So we have 0 is equal to negative 5 times 2 plus b. Simplifying, 0 is equal to negative 10 plus b. Adding to both sides 10, we have b is equal to 10, and then substituting b into the equation, and negative 5 for our m. The answer is y equals should be negative 5x. Looks like they have an error here. Negative 5x plus 10. Okay, because our slope was negative 5. So solving for b method works just as well in this case. Alright, let's take a look here at our last example. Write an equation in slope-intercept form for a line perpendicular to the line y equals 1/3 x plus 2 and goes through the point 0, 8. We'll take a look at the work. Again, start with the slope. The slope that they give is 1/3. We want perpendicular to that, so therefore we'll have a perpendicular slope, which is a negative 3. We're going to use the point slope, y minus y1 equals m quantity x minus x1. Plug in the information that we know. We have y minus 8 is equal to m, which was, not just m, we already know what m is, negative 3, a quantity x minus 0. Distributing, we have y minus 8 is equal to a negative 3x. Add 8 to both sides, y is equal to negative 3x plus 8. Final answer. And we look here and we have it under C, negative 3x plus 8. Okay, again, No difference as far as solving, just adding in the perpendicular slope part or the parallel slope part, just taking a look at the equation and using the other equation's slope. Practice problems that we will all go through, okay, that you need to do are on page 191, 1325 odds, also with 29 to 39 odds, and page 200, 1 through 39 odds, and 46 through 52, all of them. Okay, make sure you show work on all of the problems for class. Thanks for watching. We'll see you next time.